Good afternoon. My name is Bobby Gregory. I'm here with another presentation for server system security. I'm covering Apparmor, HTTPS, 2S, which is Internet Information Services, and Apache, along with hardening techniques. Apparmor was first seen in Emmix and later integrated into Ubuntu, Novel, SUSE, and Madrivia. Apparmor is a Linux security module that restricts applications, capabilities, and permissions with profiles that are set per program. It provides mandatory access control, which supplements the more traditional Unix model of discretionary access control. Mandatory access provides access and permissions on a need-to-know basis. The mandatory access control system is a kernel and is enhanced to configure programs to a limited set of resources. Apparmor is installed by default on Ubuntu systems and can be checked by running this code, AA lowercase dash status. Apparmor works with a simple path-based system. Now, profiles of the application determine what files and permissions may be required or used. Some packages do install their own profiles, and additional profiles can be found in Apparmor profiles packages. That's once you go through the installation or just view the installation of Apparmor. Now, the kernel is a querying kernel, and before each system, and it allows you to know the process is authorized to perform certain operations. Now, the profile-based security system of Apparmor functions for profiles that are created for each individual application. Now, the set of rules for those applications will dictate what resources and directories, network access, and applications they're allowed to access or denied access to. Now, the path-based access control system is based on file path names and is used to control the access of application, making it easier to configure and maintain. Now, the way that Apparmor acts is in modes. Now, the enforcement mode actively enforces restrictions and is defined by those profiles. So any action not defined or permitted by the profile will result in access denial. The complain or permissive mode, generally this mode is used for testing. You log violations based on the profile rules and is monitored but not enforced. This is for administrators to monitor these without interrupting the normal operations of the server. As I covered before, you have the path-based and the profile enforcement, and also there's a learning module which helps create profiles by logging the actions of applications. And once again, this is just for administrators. On this slide, it's pretty much the same as the previous, just more information about it. Now, coding examples for Apparmor. Say if a user wants to enable or disable Apparmor, you can run this code, configure underscore security underscore app my equals yes or no. Now, if the user wants to set Apparmor as default security module, you can go ahead and do security equals Apparmor, or the last one, Apparmor profiles. They are stored in that particular code there, or /etc /Apparmor .d/. Now I'm gonna go over HTTPS, which is different than HTTP. HTTP is the way that you actually like access the internet, but the S in HTTPS is for you securing it. Pretty much it's just a hypertext transfer protocol, and it protects the sensitive data such as your login credentials, your personal information, and your payment details. Now, you can combine HTTPS and SSL and TLS protocols, which are used to secure the communication by encrypting data between the server and the client. Okay, SSL and TLS are two different things, but they're similar. So SSL is secure socket layer, and it's a communication profile. It sets the rules and secures the connection between devices and applications on the network. There's trust and authentication, which is created, and the credentials are shared over the internet. SSL is an older technology, so we have transitioned to more updated technology such as transport layer security, which is the updated version. Now, they both use handshakes to authenticate a server's SSL or TLS certificate, is where both parties exchange cryptographic keys, And once those keys are authenticated, the server and the client can communicate. Now, there's a difference between SSL and TLS certificates. SSL is an explicit connection, and TLS is an implicit one. TLS has fewer steps, and it does reduce the cipher exchanges and speeds up the whole process. For the most part, SSL certificates are no longer in use, and most TLS certificates are incorrectly named SSL. But this does not interfere with validating and authenticating those certificates. Okay, I'm gonna cover HTTPS, which is the information with the information Internet Information Services, and Apache. Now, 2S or Internet Information Services is a web server for Microsoft and is primarily used for Microsoft on their servers. It's Windows based, comes pre installed, and has features for Windows Client like Pro and Enterprise. It's used to host a variety of websites and web applications, and it does use HTTP, HTTPS, FTP, FTPS, and more. I've not covered those during this particular presentation, but I more likely will go in more detail about those in later presentations. Now, the way that 2S is built for Microsoft's ASP.NET framework, and it allows developers to run their applications built using .NET. And it also supports other languages like PHP and Python through extensions. And of course, it does use SSL and TLS, and also uses request filtering against threats such as SQL injections and cross-site scripting. Now, continue with the Internet Information Services. It's a modular architecture and allows administrators to enable and disable specific components based on their needs. These modules handle authentication, caching, logging, URL rewriting, for example. Now, it can be configured to handle load balancing multiple servers, which does improve availability and performance. It does keep a detailed log of server activity to monitor servers and track performance metrics. Okay, we're talking about Apache now, which is an open source web server. It supports HTTP and HTTPS. It supports configuring multiple virtual hosts, allowing you to run different websites on the same server, and each of those will have their own SSL and TLS certificate. This can be configured by using the less than virtual host greater than directive and Apache configuration files. Now, administrators can specify different SSL and TLS settings for each virtual host. And also, you have a protocol and cipher configuration, which allows you to fine-tune SSL and TLS protocols and ciphers that are enabled. Now, administrators can disable the weak protocols like SSL 3.0 and TLS 1.0, and then configure strong ciphers for enhanced security. This is one of the hardening techniques that I will talk about and mention in later slides. Now, you have the SSL and TLS options, and you can use a variety of those, such as SSL protocol, SSL cipher suite, SSL honor cipher order, and customize those security settings, enabling HTTP strict transport or HSTS and to enforce the HTTPS security protocol. Now I'm talking about Apache and 2S because they're kind of similar in the way they work, but they have different application processes, as you could say. Now Apache and 2S can be used on the same server or multiple servers by configuring the ports. One server can act as a reverse proxy to forward requests to other servers. And Apache and 2S can coexist on the same server, but they have to have different types of applications. Now, Apache uses PHP, Perl, or Python applications, and 2S can be used to serve ASP.NET or ASP.NET Core applications. Those are what they're designed for. Now, you can bind Apache and 2S to different IP addresses on the same server, with each server handling requests to assigned IP addresses. Now, if you need to have a physical separation, you can use a virtualizing technique like Hyper-V, VMware, or containerization solutions like Docker. Now, these are different ways you can configure Apache and 2S to kind of work together if it's needed. Now, I'm going to go over the hardening techniques. Um, Now, these kind of apply to both systems. So you must disable outdated and vulnerable protocols such as SSL 2.0 and SSL 3.0. You can enable TLS 1.2 or TLS 1.3 and then configure those ciphers. Now, for 2S, use a cipher tool like 2S Crypto to make configuration settings easier to configure. Now, for Apache, like I said earlier, you're going to disable weak SSLS and TLS protocol settings that allow 1.2 or higher. Now, just as with 2S and Apache, you must configure strong ciphers, and you can use things like SSL Cipher Suite to only use secure algorithms. 2S with 2S, you can configure the HTTP and secure headers to prevent cross scripting, clickjacking, and you can use headers such as X content /type /options or X XXS protection and X frame. Now, 2S, you can use managed patch solutions such as Windows Server Update, which is pretty much an automatic way for you to continue to have the patches that you need to keep the server updated. Now, with Apache, you can configure headers using a header directive and Apache file configurations. Headers like content security policy, strict transport security, and referrer policy. Now, you can use command like for Apache, such as Apache CTL slash capital M to see what modules you have enabled, and that way you can get a better idea of which ones you want to take away from Apache or add to. Now, now for Apache, of course, like I said, disable the weak SSL and TLS protocols. And always use strong ciphers, and again, use SSL Cipher Suite. Now, with both of these systems, they can be hardened using similar techniques, using specific configuration modules, port assignments, and then you can also use third-party platforms. And most of the third-party platforms normally and should give you more options to configure in a more detailed way. Administrators' knowledge of these SSL and TLS protocols and specific needs for their security policy will make it easier to keep the configuration streamlined and efficient. Um, that is all for my presentation for today. I covered Apparmor, HTTPS, 2S Information System Services, and Apache, and the hardening techniques. Thank you for your time. You have a good day. Bye-bye.